Alright, so as discussed in the earlier video, rectangular summation, RM, LRM, MRM can all be used to find or approximate the area under the curve. So here's some examples of LRM. So which one is the most accurate? I'll tell you, it's this one. As the number of rectangles increases, you get closer to the actual area under the curve, which is represented here. And you can see that like pretty obviously by the drawing. This is like way of an underestimate, this is way of an, this is way of an overestimate, this is way of an underestimate, whereas this is like totally under the curve more or less. So that's more accurate. So if you want to find the actual area under the curve instead of just approximating it with rectangles, there is a solution with calculus. There is this thing that I drew here. This is a limit, which was discussed in another person's project, where this is just the number, this represents the number of rectangles, and this just means summation. This like whole fancy thing just means summation, like that's an initial value, but that's not really relevant. And this represents the area of the rectangle, because this is the height of the rectangle, like this, f of x, and this is the width of the rectangle as it's the difference between two x values. So that would just be like this little x right there, and like this. And if you take all of these together, the limit of the number of rectangles going to infinity of the sum of the areas of the rectangles, you then get an integral. So this is just a fancy way of writing this, and it's what calculus is based off of. So this is an initial value, as shown in the graph, that would be A. This is the finishing value. And then this is the function that you're trying to find the area of the curve under. If you notice, this kind of looks similar to this, because this again is the height, and this dt is kind of like the difference in x's, so it's kind of like the delta x. And if you also think about it, this doesn't really have a value typically, and delta x is going to 0 as this goes to infinity, because the rectangles get smaller and slimmer and slimmer and slimmer to eventually just look like that. But yeah, this is what a definite integral is.